Thank you very much, Sharon. Thank you all for attending. I appreciate you taking the time today to listen to our webinar about Tier 3 gasoline standards and what we can do as XOS to help you. To start off, we want to always start off with a safety topic. I'm based in Houston. It's starting to warm up now. Depending on where you're at, it will eventually warm up. Working in refineries, it is very important to stay hydrated and to think about the heat. Nomex is the miracle fabric that provides no warmth in the wintertime, but traps in all the heat in the summer. You will build up heat, sweat, and it's very easy to get overheated when you're working in the refineries. Drink plenty of fluids before you feel thirsty. If you feel thirsty, at that point, you've already started to get dehydrated. So you want to be drinking plenty of fluids throughout the day. You would want to avoid caffeinated beverages, so sodas, coffee, energy drinks, and stick with water, or possibly you can do Gatorade, which does have a lot of the electrolytes, which you would be sweating out. You can, if you can, adjust your work schedule. It is definitely going to be cooler in the mornings, so if you can do work early, outdoor work early in the mornings, it's best to schedule it that way. And then during the heat of the day, see if you can work indoors. If you're out working in the heat, take rest breaks and schedule your breaks. Typically, depending on the weather, 15 minutes in a cool place every hour is kind of a standard. You definitely want to stay safe and stay healthy when you're working in the refineries. So now we'll kind of get to the meat of the topic. What is the job of the refinery to maximize production of what? There's a lot of products that are being put out. Gasoline, diesel, jet, asphalt. Really, it's money. The refinery is going to operate in a way that would produce them the most money. That could be gasoline, pushing more production towards gasoline. As margins increase on diesel, you're going to start pushing towards a diesel production. That was a trick question, of course. You definitely don't have a specific product in mind. One of the biggest costs that a refinery incurs is the crude, your feedstocks. Since that's going to be the largest cost that the refinery is going to spend, you want to maximize, buy cheaper crudes if you can run them. We're seeing, obviously, now a wide variety of crude slates that are available. Crudes that are available from Canada, obviously, has become a very big producer and supplier for the U.S. market. Also, within the U.S., the light tight oils that are being produced. All these crudes have varying pluses and minuses, if you will. Some may be lighter and sweeter. Some may be heavier and sour. Some may contain various contaminants that can cause problems throughout the refinery. So what happens is the crude buyer is going to be looking for the most opportune crude that can be run in a specific refinery, and oftentimes the refiners are left with trying to figure out how they're going to run it. Your opportunity crudes do represent a slight advantage in terms of cost. Some of the heavier crudes or sour crudes may be 5, 10, 15% less. When you've got $100 per barrel crude in the market, a 10% advantage is quite a bit. But when you've got $35 crude, now that advantage has shrunk. You've taken a $10 advantage per barrel down to a $3.50 advantage, which may or may not be worth it to try to run these more difficult crudes. Crude schedulers, that is their job, their biggest headache is trying to figure out how they're going to take these crudes that the crude purchasers have bought and run them safely within the refinery. Just as an illustration, this is information from the EIA website on crude quality. And really, this is from 1985 to 2015 with the gravity and the sulfur content of the crudes that are being run throughout the U.S. And if my pointer is working, one of the things we see is a trend sulfur increasing. And obviously, with technology, we are getting better at desulfurization, so there's more of an advantage to running those high sulfur crudes. On the flip side, you've got the gravity here, and that is just how light or heavy that crude is. Crude is getting heavier. And again, heavier crude is typically going to be cheaper. The equipment in the refinery has been developed to make that more cost effective. Now, one thing of note and interest is right here in 2014, you'll see a jump in the gravity of the crude and kind of a leveling and a little bit of a lower of the sulfur content. Reason being the introduction of the light tight oils, the shales that are produced domestically. The Bakkens and the Eaglefords are typically very light crude, and they're typically very sweet, very low sulfur content. They do present their own share of problems in terms of how it's going to be treated, and therefore they're cost effective, but they do pose new problems. As these new crudes are being introduced into the refineries, they must be treated accordingly. And I apologize, one thing I did forget to mention, if you do have questions, please feel free to go ahead and enter those. That way we can get to them at the end. Tier 3 standards. So the EPA has set specific sulfur limits to be attained by all the manufacturers of gasoline. So in 2004, the sulfur limit was 120 ppm. Tier 2 went into effect in 2006, and that dropped your sulfur levels down to 30 ppm. What's happening January 1st is the sulfur levels in gasoline will be dropping down to 10 ppm. And there are specific standards in terms of smaller refineries are able to go until 2020 before they must comply with these standards. But at 2020, all refining will be at the Tier 3 standards of 10 ppm. Why is this being done? So when the gasoline is burned with the sulfur content, you're generating SO2, SO3 that are going out into the atmosphere. Two things are happening. One is the acid rain. And I know that some of us that are a little bit older have heard about acid rain for years and years. That is from the sulfur, this SO2 reacting with moisture, with water in the air, and it's forming sulfuric acid. So by lowering the sulfur level in the gasoline, you're going to obviously be controlling the formation of acid rain. But more importantly, there's a lot of health implications. So SO2 is a trigger for asthma. It's a trigger for breathing respiratory issues. So the EPA has put a number where they're saying between $6.7 and $19 billion per year will be saved in health benefits. And it's in the form of reduced deaths, reduced hospital visits, reduced respiratory infections, and the big one is 1.4 million lost school days and work days that will be saved. All this information is available on the EPA's Tier 3 website. Certainly encourage you to take a look. It's a very interesting read. So just like we've talked about, you've got sulfur in the crude. This crude is cheaper, but the problem is now you're going to have to remove that sulfur. The method on which you're going to do that, there's desulfurization, typically in hydrotreating the capacities. So you can see, once again, this is the sulfur content that has been rising over the years. Here's your hydrotreating capacity. And from 1985 to present day, your desulfurization capacity has nearly doubled. And you can see, again, ramping up for the Tier 2 standards that kicked in 2006, a big jump in the hydrodesulfurization capacity. So this is something, obviously, the market is preparing for, but this is something that does come at a cost. So refineries will spend millions of dollars per year for desulfurization, and you've got hydrotreaters throughout refineries. So you can see on your streams coming off of your crude unit, your light naphtha, your heavy naphtha, your diesel cut, your feed going to the cat cracker, and then feed or the FCC gas out of the cat cracker. You're going to be doing a lot of desulfurization through the process. Desulfurization costs a lot of money. Hydrotreaters cost a lot of money in the form of capital and then operating costs. The method of running a hydrotreater is you take your stream to be hydrotreated, desulfurized. You're mixing it with hydrogen. You're heating it up, and then you're running it over a catalyst bed, which is an exothermic reaction, so now you're creating even more heat, which then needs to be cooled. The sulfur in your hydrocarbon stream will react with the hydrogen and will form an H2S gas. The H2S gas leaves the liquid hydrocarbon with the hydrogen. So you've got H2S, you've got in that hydrogen stream that then goes off for further treatment. You've got amine treaters that are local on the hydrotreater unit, but then you've got a amine unit typically within the sulfur unit, the sulfur recovery unit. So there is a lot of money, a lot of energy, a lot of hydrogen, and a lot of catalyst that is being spent to remove this sulfur. There's also the octane loss that is generated, and I'll speak a bit later on that. But there is a lot of money that the refinery spends and that is required and will have to spend more with these regulations coming up. So what the refinery, or what the EPA is saying, is it will cost less than a penny per gallon to comply with these standards. This was a number that was put out in 2014. I think that industry disagrees with that. I've seen anywhere from 6 to 9 cents per gallon that it will cost. I think the truth is going to lie somewhere in the middle. The big thing that, again, that we're looking at is money, but there's also an increase in greenhouse gas emissions. The reason being is hydrogen has to be generated or is generated at the refinery. You're taking natural gas, methane, you're mixing it with steam, you're heating it up through the hydrogen unit, and with that you're generating your pure hydrogen, but you're also ending up with carbon dioxide, which is a greenhouse gas, as a byproduct. So the more you have to hydrotreat, the more hydrogen you're generating, the more greenhouse gases that you're generating. Again, optimization is always going to be critical. Another impact is the EII, which is your energy intensity index. That is, every refinery is benchmarked and gauged on how energy efficient they are. So if you can maximize efficiency, you're going to have a positive impact on your EII. And from a catalyst standpoint, it's very, very expensive, but even bigger is it has a finite life. You have to take that reactor down, that unit down, shut everything down, clear it, and replace all of the catalyst, which you've now got a downtime of 2 to 4 weeks before you're actually producing product again. That catalyst has a very finite life, and catalyst does not die, it's murdered. So how you run that unit, if you are running it a bit harder than you should to comply or to try to get your lower sulfur levels, you will need to replace the catalyst in a more frequent basis. Loss of octane, I mentioned it earlier, but a lot of the streams that are blended into your gasoline already are hydrotreated, low in sulfur, but you'll see that going to the cat cracker, your fluid catalytic cracker right here, that's where a lot of your gasoline components are generated, and it's a very high octane component. So it's critical that the cat cracker is running properly, and it's critical that you're not removing the octane. What happens is right here at the tail end, if you are doing post-treatment of your cat feed or your cat gasoline, if you're treating it to remove sulfur at that point, you're also converting olefins. Olefin is octane. What happens is that octane number that's being lost, if you're over-treating, over-removing sulfur, you're also removing octane. It's a huge, huge cost to the refinery. So you really want to make sure that you're monitoring and optimizing that area because you will have to then make up with reformate, which is from the reformer. Again, if you're shifting more production to the reformer, that's going to be more expensive. So really, you need to make sure that you're optimized. And I think that here's really where we tie in. The refineries need to comply with this. The best way to make sure that you are running efficiently and to make sure you are maximizing profits, maximizing dollars, and that's what the refinery's job is to do, is to monitor. And that's really where XOS can help, and this is really where we've excelled in the industry. We've got some benchtop analyzers and online analyzers that can help you really give the feedback that you need to be able to operate properly and to make the most amount of money, most profits. To kind of get into the technology, we'll start with just an X-ray fluorescence, just a very general overview. It is a technology that has been used for many years in the petroleum industry. It's understood. It is very reliable and predictable. It's an easy test. There's no combustion, and it's little to no sample prep. So it's a test method that has been very successful in the past. Here is just a typical energy dispersive XRF. This is kind of a basic XRF. And what you've got here is an X-ray that's being generated here. So it's generated in a polychromatic beam. What that means is you've got your energy at which the characteristic energy that you really want, but then there's also going to be a lot of background. So that background is going to limit your levels of detection, but with that polychromatic beam, you're focusing it on your sample, and then what happens within the sample is you've got your electron. Electron gets bumped out of the inner shell of the element that you're measuring. Once that electron leaves, you've got an electron in a higher energy state that will drop down into the inner shell. When that happens, it fluoresces, gives off energy. That energy then is at a specific wavelength that a detector can monitor. So here you've got your fluorescence being generated over to your detector. And what you'll see is, again, you've got a lot of background here. Well, when you get your peaks, they're not going to be very much higher than your background. So as a result, your LODs are not going to be very low. Wavelength dispersive, so your WDXRF, is a bit more advanced. Same principle in that you've got your X-ray that's being generated in a polychromatic beam hitting your sample, and again, same, it's really, there's not a lot of difference here. You've got a lot of background that is, background energy that is going to interfere with your results. Fluorescence can be filtered, and that will remove some of the background, some of some of the things that will it'll be able to lower your LOD. That then is bounced off of a flat crystal, and then your sulfur and chlorine, your elements, are then measured at the detector. Again, you're lowering the background, so that gives you some lower LODs, but there is obviously room to improve. This is XOS's technology. The company was really formed based on the doubly curved crystal. What that is the optics. The optics that are used is really where XOS started. And that's really what gives the advantage and the low LODs that are required for these Tier 3 standards. This is just kind of an overview of what the system looks like. In a little bit better detail, a little graph of what you're seeing. And to start, again, you've got your polychromatic X-ray. When it hits that first optic, that doubly curved crystal, you are monochromating your energy. So you get a very precise energy as opposed to here where you've got a lot of background. What you're able to do then is, with that precise energy, get a very clean result for a fluorescence, send that over to your second optic, which then is able to filter out and to give you a very clean, a very precise measurement of the element that you're looking for, sulfur in this case, and with very low background. This is really a great explanation of how how this is really being done. Again, we're being able, with the monochromating of the X-ray, we're able to run at lower energy levels, which is going to prolong life of the tubes and really just improve on safety and on the reliability. On the collection side, we're really able to, again, get a very clean sample, or clean result with very little background. We're looking at 10 times better than traditional WDXRF. With the simple design, the simple operation, it's a very favorable analyzer for use. Now, we've got some performance data that we have here. We've done a lot of work with ASTM. There is the reproducibility, which is the big R, and repeatability, which is little r, that are typically looked at. Reproducibility is where you've got two labs, two results from two different operators doing the same method. How close are the results? And really, that's a good measurement of the simplicity of a test and making sure that everybody can operate and do the same test the same way. obviously keeping it simple is very, very important. You've also got repeatability. And repeatability is, I'm doing this sample over and over and over again. What kind of numbers are we looking at? So we've got ASTM data here. And this is obviously in the scale, it's a bit higher than what you're looking at for Tier 3, but it gives you a very good indication that the MWD-XRF is very favorable for producing the very solid, very reproducible results. It's good for the higher sulfur streams. Jet is obviously a higher sulfur content stream. Crudes, we can go up into percent levels, but that test method gives you a lot more accuracy, a lot more precision in measurement of your sulfur. So more specifically, what we're seeing for Tier 3. So Tier 3 is 10 ppm right here. The numbers that we would be looking at right in this region, the MWD-XRF provides favorable numbers. And we actually do have actual numbers of ASTM data. This is actual cross-check data that we have through ASTM. Every month there are samples that are sent out. So you can see that this right here is the actual ppm level of the samples being sent out through various methods. And these bars indicate the different methods. So the 7039 is the test method that all of our Cindy analyzers use, including our onlines. 2622 is the standard for measurement within the industry. 7039 is also used. We do have analyzers that measure both. And then you've got also 5453, which is UVF. So through these different test methods, you can see that the MWD-XRF, the XOS Cindy, does perform better than traditional 2622 and UVF. Here is our product line for sulfur analyzers, both benchtop and for online. We've got three different sulfur Cindy measurements. So we've got all of them measure 7039. We do have a model that measures both 7039 and 2622. With these benchtops, it's all very precise, very quick test method. It is 5-minute tests. Results are very consistent and very clear, very low LOD. And you've got an LOD of 0.15 when you're trying to measure it in the 10 ppm range, well within our wheelhouse for proper measurement. We also do have auto samplers as well, if that's something to be able to test or something that you'd want to test. We do have the Cindy OTG. It's OTG. It's on the go. It's a smaller design. This is something that is used within mobile labs, or if there's ever a need where you have to go out onto a site and just do the test right there. It is beneficial for these mobile environments. Still comply with 7039, and they're a little bit higher in the LOD, but it definitely gives you a lot more of an advantage and a bit of a cost advantage as well. We do have an online model. The sulfur online is something that obviously to be able to maximize and optimize systems, having those numbers at all times definitely will help you out. So the online sulfur, we have those on hydrotreaters specifically, or on blenders, things like that, where sulfur measurement and optimization are critical. They are continuously run. They have the same calibration for whatever hydrocarbon, whether it is a diesel, a gasoline. So whatever stream, these are good for pipelines to be able to detect sulfur changes. So jet has a higher sulfur content. So if you've got a transmix going from diesel to jet, even though from density are very similar, the sulfur contents are going to be very different. So online sulfur measurement is very good for trying to minimize your transmix. There's no consumable gases, and it's very, very low maintenance. So that is really one of our big advantages, is the maintenance and how little maintenance is required. For the online, here's a little bit more information. You can see that the kit is very small. It's very compact. It can be mounted in an enclosed shelter environment. Very, very safe. And really, because you've got a flowing sample, this is really kind of the critical portion of how the measurement is done. We do have, this is what we call the dynamic window module. You've got all of the engine components, which is your X-ray and your optics, that are all contained within the inside of the cabinet. So going back to this, that engine is what we call the X-ray and the optics are all inside the box. And then we've got the window module outside the box. So this is what the window module looks like. The sample is constantly flowing through the window module. It is constantly being exposed to the X-rays, so you're always getting readings. What happens is, over that 5-minute period of that flowing sample, you're able to get a very, very accurate idea of a very accurate number of what your sulfur content is. The big advantage of that is we also can send a signal every 15 to 30 seconds. So instead of waiting the full 5 minutes, if you want, you also have a secondary reading where you're able to catch any rapid changes. If there is an issue that you have within a hydrotreater, you're able to see that within 15 seconds. That really can help out from a problem-solving perspective, but also making sure that you keep all your products on spec. The window module is designed to be able to change film. Just like typical X-ray, you do have a film, and you've got a primary window and a film that separates the beam from your sample flowing through. So the Cindy is designed that film does need to be changed. It will over time build up material, and it has to be changed. The Cindy is designed to shut the analyzer down, really just to kind of pause everything. It clears the lines and takes everything down to atmospheric pressure to where you can then advance the film. This film, typically it's done every 4 to 6 hours, and once that film is advanced, then you've got a clean sample. You're ready to go. The film will typically last 4 to 6 months. At that point, you just swap out this window module. It's sent back to XOS, and it's refurbished, replaced with new film, and then cleaned up if there's anything that needs to be done. Sydney, with these technologies, it has significant awards. These instruments are designed and engineered to run. and really that is, again, the biggest advantage that we have is to be able to run trouble-free, to be able to run without much attention. There's other systems, other analyzers where a lot of attention needs to be paid. So we really do have the advantage of that. Again, here's how we can optimize. You've got to be able to measure, what are your sulfur levels? You've got many hydrotreaters, and refineries will have 5, 10 hydrotreaters throughout. So you need to be able to optimally get the sulfur numbers to be able to hit that 10 ppm. Don't need to send out crude or gasoline that is at 8 ppm if you're required to set it at 10. This is going to save you in your EII, your energy, your catalyst. This is how you're going to save money. We do have demonstrations available. What you can do is you can contact send an email to info@XOS. You can also go through our website at that address right there, and we can bring out a benchtop model and do a demonstration. If you're not already familiar with the technology, we'd be more than happy to bring one out and set something up. I want to thank you for your time. I do want to turn everything over to Leslie Johnson. She is our applications engineer and our expert within the Cindy. And if there's questions that have come in, she can go ahead. She can answer them, or we'll go ahead and we'll answer questions. So, Leslie, I'll turn it over to you.
Thanks, Sean. We do have a few questions that have been submitted. We'll go over those. And a reminder, if we don't have time to go over any question that has been submitted, we will follow up with you offline. Our first question here I can help answer is, what are some of the best practices for getting good measurements at low levels for the new Tier 3 sulfur levels? This is actually a very common question that I get because as these new sulfur levels come in, contamination can be an issue. And basically, it comes down to common sense. It's cleanliness is key for getting these good low-level measurements, and eliminating contamination will get the best results. There are three basic ways that you do this. You look at your test area. There are some analyzer-specific things you can do. And there's also some sample prep-specific things that you can do. First of all, for your test area, just common sense is to make sure that your sample preparation and your test area is clean and clear of unneeded items. For example, are your sample cups and your pipettes out on the bench exposed to contamination? Or do you keep them in a drawer or a sealed bag? Moving to analyzer-specific items, your Cindy analyzer has a primary window, which should be kept clean. You can actually clean this window with IPA and a foam-tipped swab, and then use canned air to dry this primary window to keep it clean. I'm a very big fan of this canned air to help keep things clean and orderly when preparing samples. Your sample basket has a secondary window, and you need to keep that secondary window clean as well. You can keep the basket itself clean with IPA, and then you change the secondary window as often as needed. It can be as often, it can be daily if you're running a lot of samples and you have sample leaks or problems with contamination. It may not need to be daily. Then the third area is primarily focused on the sample prep specific items. If you do not make a clean sample, you will not necessarily get a good answer. So in preparing the sample cell, you'll want to make sure to shake or swirl your sample bottle before pipetting your sample into the cup. Let's make sure your sample is homogeneous to get the best measurement result. If you have a standard X-ray cup, rather than an AccuCell, you'll want to use your canned air to blow off the empty cup before you make the sample, and then the X-ray film before assembling the cup. Keep in mind that fingerprints can interfere with these measurements, so avoid touching the film. And do not use films that are wrinkled or become wrinkled during assembly. When you are finished assembling your sample cell, you want it to have a nice, flat, wrinkle-free surface. And of course, make sure you're using the correct X-ray film for your sample type. Typically, for sulfur, it's Mylar, but other films are acceptable, and you do need to use the same film that you use to measure the sample that you do in calibration. And then also, if you're not using an AccuCell cup, you're going to want to vent your sample. One of the points that contamination can enter is your venting tool, so you'll want to make sure that that's kept clean. And lastly, do never put your sample cup down on the empty lab bench. You're going to want to put that down on a lint-free cloth, such as a Kim wipe, or use a sample stand. One last thing here. You want to make sure to pipette instead of pouring. We found that pipetting is a cleaner way to introduce the sample into the cup, as the pouring can introduce contamination. And again, with your canned air, before you put your sample into the analyzer, actually take your canned air and blow the film off again before you put the sample into the analyzer. This will give you, these are the best practices to give you the best measurement that you can possibly get. And of course, one last common sense thing is please do not reuse samples. If you need to do a second measurement with another sample, it is best to prepare a new sample for this. Okay, let's see. I think that covers that question. Here, Sean, I think we have this next question should be for you.
Okay.
The question is, you talked about crude quality changing even within the same source. Besides sulfur, what else should be measured?
Well, that is, again, going back to the opportunity crudes. So crudes will vary greatly, even within the producers. There's crude assays that are available, and I think anybody that's been to COQA or something like that, that's always a big topic of conversation is you can buy the same crude from the same person or same company, and they're going to be very differently. So the big things are obviously chlorine, particularly organic chlorine. Organic chlorine will not be removed in the desalting process. Desalters are at the front end of the refinery that clean the crude prior to going to the crude unit. Chlorine, it's desalter. Sodium chloride is typically what is measured and removed, but that is inorganic. Organic chlorides will go right through the desalting process and then to the the crude unit tower. When that happens, then you end up with a lot of corrosion. You'll corrode the overhead because that chlorine will hydrolyze and go overhead and cause it'll then form hydrochloric acid and cause a lot of corrosion. So chlorine is very important. We do have a chloroanalyzer that measures specifically chlorine, and it's all forms of chlorine, organic or inorganic. Very important. Secondly, you've got all the other elements that are contaminants of, particularly with the light tight oils. So vanadium, nickel, iron are big ones that are a concern because what happens is that it ends up passing through it'll go through and over to the cat cracker. So you've got it goes into heavier cuts in that crude unit, goes over into to the cat cracker, and these metals are poisons to the catalyst. So within the cat cracker, it is a continuous process where you're always replenishing the catalyst. But if you have a lot of these contaminants in there, they will poison the catalyst. It's going to cost a huge amount of money. We do have what we call the Maxine. It's a multi-element that will measure 40 elements. Now, not all of them may be of concern, but we've got the elements that are going to be a poison. So that's something that we can help also monitor within these opportunity crudes. Thirdly, and another one is phosphorus. Phosphorus is sometimes going to be in the crude. Sometimes it's going to be it's in some of the drilling fluids, things of that nature. It could also be as an additive. Some of the high tan, there's high tan additives that are phosphorus based that can be added. Now, obviously, it depends on what type of form the phosphorus is in, but there you could. Some of the issues are creating fouling within the crude unit tower. Typically, you'll see some fouling up in the jet cut area. So monitoring the phosphorus in your crude is very important. Also, it is a big contaminant in also catalyst. So if it does make it through and goes to hydrotreaters or goes to the cat cracker, it can foul and cause problems with that catalyst as well. We do have a Phoebe that will measure specifically the phosphorus, and that's also measured in the Maxine with the multi-elements. So those are really kind of within the opportunity crudes where what we can do to try to help out and save the refinery money. Pass it back to Leslie.
Actually, Sean, I think that's it for the submitted questions. So if there are no additional questions, I will turn the session back to you.
Thank you very much. I appreciate it. I really do want to thank everybody for taking their time out today. I really hope nobody fell asleep, and I hope that you enjoyed the presentation. If there's any questions, there's my contact information that's listed. Feel free to call me, and we can get anything that you might be looking for. Again, thank you for your time, and I appreciate everyone attending.